Good morning everyone. Today we are going to discuss about the problems based on the joint probability distribution. In the last class we discussed about what is joint probability distribution and various terms involved in it. And problems we'll be discussing today. Example, a joint probability distribution is given by the following table, where x takes the value 1 and 3, y takes the value minus 3 plus 2 and 4, and x and y it is 0.1. When x takes the value 1, y takes the value 2, it is 0.2, and when x takes the value 1, y takes the value 4, it is 0.2, and when x is 3 and y is minus 3, it is 0.3 and 0.1 and 0.1 respectively. This is what has been given in the data. What we need to find out is find the covariance of x and y, and also verify that x and y are statistically independent variables. These are the things we need to determine. We discuss what is the covariance formula. So first of all, we have to find the marginal distributions of x and y by adding all the respective row entries and the respective column entries of the given joint probability distribution table. So what do we get here is, when x is 1, 3 and f of x will be 0.5 and 0.5. Let me come back with this. When x is 1 and 3, so when we add this 0.1, 0.2 and 0.2, it will be 0.5. Similarly, 0.3 plus 0.1 plus 0.1 will be 0.5. You can observe here. Similarly, when it comes to the second table, that is for y, minus 3, 2 and 4 are the headings. So how do we get 0.4, 0.3 and 0.3? Let us look at back. For minus 3, when we take column heading is minus 3. When we add this column total, it will be 0.4. When we add the column total of 2, it will be 0.3. And when we add the column total of 0.4, it will be 0.3. So we are getting 0.4, 0.3 and 0.3 respectively for minus 3, 2, 4. This is the values we are getting it. So this is how we have to find out the marginal distributions of x and y by adding all the respective row entries and then the column entries. Mu x, it is nothing but e of x, is given by x into f of x. So what is our x? Means 1 into 0.5 plus 3 into 0.5. You can see here the x values and then the f of x values. 1 into 0.5, 3 into 0.5. Similarly, when I go for a e of y, it will be minus 3 into 0.4, 2 into 0.3 and 4 into 0.3. So, we are taking mu x is given by ex, that's given by x into f of x, that is 1 into 0.5, 3 into 0.5, that gives us 2. Similarly, mu y or ey is given by y into g of y, that is given by minus 3 into 0.4, 2 into 0.3, 4 into 0.3, that gives us 0.6. Similarly, when we take this e of xy, it is given by sigma x into sigma y of xy of p of xy. That is given by x into y into p of xy. So it is 1 minus 3 and 0.1. plus 1 into 2 into 0.2. Let me explain the first part so that it will be more clearer. It is 1 into minus 3 into 0.1. This is given by 1 minus 3.1. So 1, 2.2. Let's see. 1, 2.2. 1, 4.2. 3 into minus 3 into 0.3. If you want, we can have a joint distribution table so that it will be easier here. We have minus 3, 2, 4 and 1, 3. So 0 0.1, 0 0.2, 0 0.2 and 0 0.3, 0 0.3, 0.31 and 0.31, 0.1 and 0.1. So that you can remember, and then you can get back to this. So respectively it has been multiplied, and that gives us equal to 0, because we have some of them are negative over here. You can observe here this is negative and this is negative. So when you add everything, it will become 0. So we are getting E of xy is 0, and covariance of xy is given by E of xy minus mu x into mu y, that is 0 minus 2 into 0.6. This we have calculated 2 and 0.6. So when we take this, it will be minus of 1.2. Next we have the second example. The joint probability function of the two discrete random variables x and y is given by f of xy is c of 2x plus y, where x and y can assume all the integral values such that x is varying between 0 to 2, y is varying between 0 to 3, and f of xy is 0. Otherwise, find the value of the constant c, and p of x is equal to 2, y is equal to 1, p of x greater or equals to 1, y less than or equals to 2. So this is the values to be found. Solution. Given f of xy is c of 2x plus y and 0 otherwise, 2x plus 5 when it is 2x plus y when it is x is varying between 0 to 2 and y is varying between 0 to 3, and it will take the value as 0 otherwise. And also given x and y are discrete random variables. Therefore, the joint probability distribution table is as follows. We can draw the joint probability distribution table. You can see x values are 0, 1, 2 and y values are 0, 1, 2, 3. Why? Because you can see x is varying between 0 to 2, y is varying between 0 to 3. And how to get the value is c of 2x plus y. When x takes the value 0, suppose y takes the value 1, then it will be 0 plus 1, that will be 1 times of c. Like that it has to be calculated. Here 0 and 0 both are 0. 2x plus y. Supposing if I am substituting, let me take one example here. 2 into 0 plus 0. If I take 2x plus y, where x is 0 and y is also 0, then it gives us equals to 0. Let me see for the other one. 1 and 0, that is 0 and 1, that is 2 times of 0 plus y is 1. It is multiplied with c. So what do we get? It is equals to 1c. Hope it's clear. 0 and 2. Let me take the second row and the second column. Both are 1 and 1. So what do we get? C times of 2 into 1 plus 1. So what do I get? 2 into 1, that is 2 plus 1, 3. 3 times of c. That means when I am taking 1 and 1, both it should be 3c. This is how it has to be calculated for the marginal distribution, the table, joint distribution table we have to calculate in this manner. Hope it is clear. Okay. Now, we want to find the value of c. From the properties of the PDF, we know that the sigma x, sigma of x, sigma of y of p of xy is equals to 1. That means we need to add all these values. 0 plus c plus 2c plus 3c plus etc. Everything when we add, it should be equal to 1. This implies when we add all these things, we will be getting 42 times of c, or c is equal to 1 upon 42. So we can replace this value of c in the table. C value is obtained. So here what they have asked us to find out is p when x is 2 and y is 1. So when x is 2 and y is 1, you can look at the previous table. X is 1 and y is 2, it should be 4c, where c is 1 upon 42. That means it should be 4 divided by 42. Sorry. X is 2, y is 1. So it is 2x plus 1. It should be 5c. Therefore, it will be 5 into 1 by c, that is 42. When x is greater or equals to 1 and y is less than or equal to 2. So greater or equal to 1 means 1, 1, 0 and 1, 1 and 1, 2, and greater or equals to 1 means 2 also will come, 2, 0, 2, 1, 2, 2. Like this, all the combinations we will be getting, that is 2c, 3c, etc., which gives us 4 or 24 divided by 42, that gives us 4 divided by 7. Third example, a fire coin is tossed thrice. Random variables x and y are defined as follows. X is 0 or x is 1 according as head or tail occurs on the first toss. Y is the total number of heads. So to determine the probability distribution of x and y, the joint probability distribution of x and y, the covariance of x and y. So this is the thing we have to find out. Solution. The sample space consists of HHH, HHT, HTH, HTT, THH. That is totally 8 combinations we will be getting. Because the 3 combinations means 2 to the power of 3. Thereby we will be getting 8 combinations. The probability distribution of x and y, that is the marginal distribution when you are taking. For x it is 0 and 1. Therefore it is f of x is half and half. For y it is 0, 1, 2, 3. You will be getting 1 upon 8, 3 upon 8, 3 upon 8 and 1 upon 8. These are all the combinations we will be getting. Here 0 means 0, the thing. How it is coming is 1 upon 8. Only one combination we are getting out of 8. And one head out of 8. Only one head out of 8 means the 3 combinations we will be getting. This is one. This is another one. Sorry. Only the 3 combinations we get it. Similarly, 2 heads out of the all combinations means it will be 3 out of 8 and 1 out of 8. These are all the combinations we are getting it. The joint probability distribution for x and y is given by when x is taken as 0, 1 and y is taken as 0, 1, 2, 3. So we have the table like this, that is 0, 1 by 8, 2 by 8, 1 by 8, etc. These are all the values. And when we add up all this, it is 1 upon 8, 3 upon 8, 3 upon 8, 1 upon 8. Similarly, when we add up the row, it will be this one. Row is added, it will be one half and half. And this column again, if we add, it will be 1. And this row, if we add, it will be 1. That is what a probability distribution function says. So next, e of x or mu x, let us find out. That is x into f of x. So when we add up everything, it will be half. Similarly, mu y is given by e of y, that is y into g of y, which gives 0 into 1 by 8 plus 1 into 3 by 8 plus 2 into 3 by 8 plus 3 into 1 by 8. That gives us 3 by 2. That is mu y or e of y, mu x or e of x. That gives us half. Next comes e of xy or mu xy, that is sigma, double sigma of or double summation of xy of p of xy, that gives us 0 plus 1 into 0 into 2 by 8 plus 1 into 2 into 1 by 8 plus etc. That gives us half. Next gives the covariance of x and y, that is e of xy minus mu x mu y, and we have already calculated these values. Half minus half into 3 by 2, that is minus 1 by 4. Thank you.